Hi everyone, Tom and Shannon here. Finally arrived in San Jose. So this is a little bit later than we had intended. The way we're going to do this is we're going to upload these videos in the morning, US West Coast time. So if you're watching in the UK, you can expect this every afternoon. So this is going to be a high-level recap of day one. So we're not going to go into anything in too low-level detail as part of this. But what we will do is we'll include any kind of useful links and materials in the actual description below the video. So if we come across something that we think you could look at in a bit more depth, we'll direct you towards that. So day one was kind of an extra day. You could either do like a standard pass or a silver pass. So we went for the silver pass. We did a couple of half-day workshops. So between us, I think that covered about 12 hours in total.
Yeah.
I would guess. So what I'm going to talk about is largely architecture. So we were attending architecting a data platform and a session on fraud detection. And Shannon?
Yeah. Most of my tutorials were a lot lower level than that. So going into individual technologies and machine learning apps and time series, really.
Yeah. So we'll kind of try to rattle through this fairly quickly. So the first session I attended was delivered by a company called Silicon Valley Data Science. So there's a link included in the description where you can go to get the full slides from this presentation. So I would recommend that you do that because there's actually quite a lot of good slideware there covering this. Now, what this really covered was kind of what a modern data strategy looks like for an organization. So how do you actually look at this huge big data ecosystem, the Hadoop ecosystem, and pick the different components that are going to allow you to do interactive, real-time, batch, and how you're going to actually be able to flexibly get that out to people in your organization. So it kind of starts with what do you actually do with data? What are your business goals? So are you going to try to attract new customers? Are you trying to improve automation? You kind of start with that, and then the role of the architect in this is now moving from a situation where it was just about picking the right relational database to looking at all these different specialized components. So whether it be a graph database, document database, key value store, columnar store, and trying to work out how do you put all this together to achieve those goals. So there was an interesting pipeline that went up as part of this slide, and I'll come to it on the next slide in a bit more detail, but effectively any kind of data architecture using the Hadoop ecosystem at the moment covers this kind of pipeline. And I thought it was interesting that they've actually split out like data acquisition and data ingestion into kind of two separate components there. So the whole idea that if you're a big organization, it's actually a really big challenge to go out there and actually get the data from people who don't necessarily want to give you it.
It's been a big challenge for us as far as I know.
Yeah, it has.
Yeah.
It has. And that kind of leads on to this idea that they talked about the experimental enterprise, which I thought was a nice kind of pithy line. So it's basically about if you kind of have all of your data in this one big operational system that has really tight SLAs, your ability to be flexible and to do like exploratory analysis on that is going to be really limited because people are just not going to want to give you access to that. So the idea about having something which is more modular, more flexible, and which uses these kind of different specialized data stores for different use cases is going to help you with that. So I kind of split that pipeline out into like a hierarchy of needs. So the whole idea of this is that the things along the bottom are what you need to address in order to get to the higher value stuff at the top. So ultimately what you want to do is have reliable pipelines for data ingestion. You want to have the right kind of persistence stores for that. And then what you want to do is ultimately be getting up to that analytics and engagement layer. And I can't remember where I stole this from, but the idea of an engagement layer I thought was really good. So it actually incorporates not just visualization. It's kind of visualization. It's usually the thing that you see in that box. But actually it can incorporate any way that you get the data in that platform out to other parts of the business. So the idea presented in this session was like using a microservices architecture. so what they call data services,
Right.
which was kind of a nice rebranding of that. So it's kind of microservices as applied to a data platform. So exposing your data to applications in that way, as well as visualization to end users. So like I say, if you want to get more detail on this, I would recommend you look at the links below, go to the slides. We're going to kind of move on to talk about the afternoon session, which was, again, Hadoop architectures, but it was specifically fraud detection. So there's quite a lot going on this slide. Where this is taken from is a book called Hadoop Application Architectures, which I'm sure you've seen. And yeah, effectively the material for this talk was taken from chapter 9 of this book. So again, link in the description. If you're interested in looking at fraud detection, anomaly detection in more detail, I would kind of recommend this, because this talks about it in a lot more detail, and you get the big, gnarly architecture diagrams, which we don't really have time to go into. The authors here are 3 chaps from Cloudera, and Gwen Shapira, who's formerly of Cloudera, now of Confluent, who are kind of the Cloudera of Apache Kafka, if you like. So just going back to this, some of the interesting things that I picked out of this were the use case they were talking about was using NetFlow data, which is like data from routers. So you're looking at kind of IP addresses, just network data effectively, and looking for anomalies. So trying to detect deviations from known patterns, and I guess detect suspicious behavior. So there are a couple of things about this. Again, this looked similar to the pipeline pattern that we talked about on the previous slide. So you have this idea of, you have a framework for ingestion, which in this case is Kafka and Flume. And we'll talk a bit more about Kafka. But effectively, one of the interesting things I took away from this was that you don't use a stream processing framework like Spark Streaming to actually do your ingestion. So it's something we've kind of looked at in the past, about whether you would use Flume to kind of dump files into HDFS, or whether you could actually have a Spark Streaming job hooked up to your Kafka or Flume pipeline, and then actually do some processing and write that out. It's not a good idea because, well, A, Kafka and Flume are like specifically designed for those things in the first place, to do that really reliably. And second, that's never going to give you actual real time or even near real time. You want to kind of get as close to the infrastructure, which in this case is Kafka, as you can. So that's going to be your millisecond latency. Storage was HBase. I know you're probably going to talk about more about Cassandra, like as an alternative to HBase. But one of the interesting things which came out of this was around using block cache. So HBase block cache is like a way of storing some of your blocks on the nodes in memory. So the idea is, if you're doing stream processing on this stuff, you don't want to go out over the network, because you're never going to get your millisecond latency doing that. You want to try to do everything as local as possible. And then finally, Spark Streaming for the actual kind of global state, like the actual, so if you're trying to like react to events really quickly, you can do it at the Kafka and Flume level, but you still need Spark Streaming to like maintain the overall picture. So if like you're trying to blacklist an IP, you need to maintain kind of like a state of what IPs you've maybe seen in the last half hour or 15 minutes or whatever. So it kind of fulfills that role.
So you keeping a 15-minute window kind of thing?
Potentially, yeah. So Spark Streaming kind of offers you this ability to have like sliding windows, so you can maintain state over like a sliding window of time. So if I see user ID or IP address, whatever, come in within that 30-second window, I can be like keeping account of that. So if something was on the network that was like polling out to a remote server, you could maintain the state in that window. So we'll move on to Shannon's more technical, hands-on sessions, which didn't involve.
This is a complete whirlwind, is what this was. Alright, so the first talk I went to today was on building machine learning apps with Spark and MLlib, ML pipelines, machine learning API, and GraphX. A whole lot of technologies trying to skim the surface on machine learning at scale, really. So the biggest challenge that we've been hitting in the last X amount of years has been doing this at scale and trying to speed up the machine learning process. So currently in the AI pipeline, we're at a state of ANI, which is artificial or automated narrow intelligence. So that means that any AI out there at the minute is very good at one thing. So for example, the chess machine that's out there. It's a good example of AI. We're on the verge of tipping over to AGI, which is general intelligence. So that's like you and me. That is getting an AI that's basically a human.
Well, you and me.
Everyone watching this, I hope. Then the next state after that is ASI, which is super intelligence. So that's whenever, that's Skynet. We're about to die, basically. Hopefully we do and don't get to that position, because we're out of control as soon as we get there. But we're about to hit that big change in the AGI, simply because of the rate of change in these technologies. Sure. It was sort of left behind in the move to all this distributed stuff. The big focus was on just getting things working and on getting transformations in place. Machine learning it tails behind a bit further, simply because of the complex nature of it. So this talk was very much skimming the surface on the technologies mentioned on the screen. So the first one that we hit were linear problems, basically, and decision trees. So this is linear regression, really, doing that in Spark and MLlib. Some nice examples were in there. Good to see this in action, good to see it in practice. MLlib's one of those libraries that isn't overly well documented, so you kind of need to talk to someone that has used it before to really see what way things are and how to use them.
Yep.
So that was good to get an example of. Then we moved on to clustering with Spark and MLlib. So clustering was k-means, and then we moved into LDA. So k-means is basically, whenever we're talking about clustering, we're talking about grouping and identifying something inside a particular topic or a cluster. In k-means, a document can only exist in one topic. So it can only exist in one individual cluster, really.
Yeah.
In LDA, that goes away, and you're really talking about saying that whether a document belongs to a certain topic or another topic, or it can belong to multiple topics, things like that. LDA had a real good example in MLlib when we went through it quite in depth. A lot of stuff went over my head, unfortunately, so I'm needing to get involved in that and look at that later. Words like, what is it? Online LDA optimizer. So you've got an online optimizer, and you have an EM, which is expectation maximizer, I think. Yes, expectation maximization.
Yeah, one of those.
Yeah, one of those optimizers. So, and if that rings a bell to you, the recommendation is to use the online LDA. It's not as comprehensive, but you get less iterations needed. So with expectation maximization, you need to run at least 50 iterations to get any real good output.
Sure.
With the online LDA, you can get it in about 30. So moving on from that, we were looking at text analytics with PySpark and Zeppelin Notebook. So Zeppelin Notebook is, I guess, similar to Jupyter and IPython Notebook, but it packages everything together. You have your Spark and your Spark SQL and your PySpark all in there, and it's quite nice. It's not what's the word? It's not in production yet. It's more of a beta phase. It's incubating, I think, at the minute. But text analytics was very straightforward. It was using the State of the Union addresses by the different presidents and comparing what they focused on during those talks. So whether a certain theme was more important than another theme, how each presidential candidate, or president in this case, ranked those themes.
Okay. So a bit of kind of meaning extraction from raw text.
It was interesting because we were looking at the pipeline of that. So you have a massive pipeline for this kind of thing. We were looking at a very small part of it. So basically extracting out, it was basically word counts on each of the State of the Union addresses and comparing them to each other.
Okay.
So you then have to take that further and do something with it.
Okay.
Really.
Cool.
So I think we can move on to the last thing in this first tutorial, which was GraphX. So GraphX is graph processing API on top of Spark. This exists to operate on anywhere where linking occurs, any data sets where you can establish a relationship between different entities, really. So edges and vertices. A good example of where we would use this is if you were to ask a question, who likes football? Who's a football fan?
Yeah.
And you were to go onto the likes of Twitter and drag a load of people down, then you want to find relationships between people to identify not exact people who are football fans, but relationships of those people. Then you can target those.
Sure.
If it was some kind of marketing campaign or something like that. Now, the challenge with graph processing in the past has been you can only really operate on subgraphs. So Neo4j, for example, will operate in subgraphs because there's just so much data.
Yeah.
So GraphX is able to operate on the full graph simply because it exposes the distributed nature of Spark and data locality in it.
There's actually a really interesting chapter in the Advanced Spark book on this as well. So that's another one for the description link.
Definitely.
Because it talks about this. So it's about doing co-occurrences with it of terms in academic papers. So it's about building up like a global graph of this kind of like body of research and trying to find like trying to think of the term. I think it was small world graphs. So it's kind of like a property of graphs that exhibit. So I think the idea is if you had like a small number of papers that were referencing each other, that would like clearly show up as a cluster, like a subcluster within the overall graph.
There's a name for that. But
I can't remember whether it's small world graphs. It could be. So yeah, that was interesting. And again, GraphX, Neo4j, those things. It's like the Donald Knuth kind of principle that if you put the data into a suitable structure, that's going to be better for actually doing that kind of processing, that different kind of processing. So I think it's really interesting. I mean, graph processing is something that we're seeing a big uptake, or at least a lot of interest in, just because of that.
Yeah, and again, it's down to the likes of Spark, making it really accessible.
Yeah.
So it is. Anyway, I'm going to leave that talk there,
Okay.
And we'll move on to the second talk of the day, which was an introduction to time series with Team Apache. So this was a data stacks tutorial on the SMAC stack. So the SMAC stack is, for anyone that doesn't know it, it is Spark, Mesos, Akka, Cassandra, and Kafka. So it's basically a full stack for likes of streaming. Well, you can really use it for a lot of things, I guess.
Yeah.
This talk is more focused on the Spark, Kafka, and Cassandra side of things, not really touching Mesos or Akka.
Mesos, I suppose it's worthwhile explaining to people, is it's like a cluster manager, so it's like an alternative to Yarn.
Yeah, that's exactly what it is. It's just another...
Or Yarn's an alternative to Mesos.
Yeah.
To be politically correct.
So again, ingestion. Tom already touched on this. So in this respect, we're talking about streaming, time series data. You were talking about something similar, actually.
Yeah.
So it's a different approach, and you were looking at alerting, really.
Yep.
So this is more just to do with processing that as it's coming in.
Sure.
So we have Kafka and Spark streaming again. No Flume in this case, so we're actually attaching Kafka directly to Spark. The processing engine again, Spark streaming, and storage Cassandra. The big emphasis on Cassandra in this talk, naturally, this is data stacks. So the first thing that we looked at was Kafka and how Kafka can be misunderstood by a lot of people, which was interesting. So the good analogy was around the restaurant. So you have the waiters and the chefs, and then you have the queue in the middle of the orders. So the idea was, how do you scale that up? Do you add more waiters, add more chefs if that was getting bigger? So then the next extension onto that was individual orders and chefs that deal with certain types of orders. So you would have hamburger specialization, for example. You would have one queue for that. So waiters bring in, they add their order if it was a hamburger to one particular one. If it was something fancy, I don't know. if you were ordering clams, can you eat clams?
I don't know.
That would go into a different queue.
I personally would not.
So you would have two topics in that respect, and this is how Kafka started to come into. So Kafka's all based on topics, consumers and producers. So then you have two topics, and you have two producers, two consumers, or X amount, Y amount. You can then split that up and partition it further. So to hook Spark streaming into that, the way you do that really is you have two options. You have a direct approach or you have a receiver-based approach. The receiver-based approach is not really recommended to use because it's basically letting Kafka handle the reads of each of the items in that topic, but that means that Spark will also need to maintain a write-ahead log. A write-ahead log to identify whether it's read a certain message or not and recompute it if it fails, for example, or if a node goes down. Receiver-based approach lets Spark handle the reading and further on from that, so it's all kept in one place. Processing again directly in Spark streaming, you have all the handling of that directly into Cassandra, directly into Kafka. So you have Kafka stream in there that you can use. You have Cassandra connectors, which enable Spark to directly execute the likes of CQL or Spark SQL on Cassandra instead of CQL.
Yeah, so this is an interesting use case actually I've heard come up a few times, is that because Cassandra is effectively this big NoSQL database.
Yes.
If you want to get ad hoc querying on something like that, you basically co-locate Spark on the nodes, and you now have this kind of SQL compliant facade that sits on top of that. So that's
exactly the use case for it, because Cassandra doesn't have joins or anything like that, or any of the real analytical side of things, so you have to use the likes of Spark SQL to touch that. Now, whenever you mention co-location, we'll get into that in Cassandra. So Cassandra, as Tom said, it's a big NoSQL database. Basically, the whole idea of it is it's really simplicity and keeping things, optimize your schema really to optimize everything. So you really think about your partition and your primary keys up front.
Yeah.
It has this notion of partition key and clustering. So your partition key is where that data is written to the disk.
Yeah.
And then you have clustering key, which is in the header then. So you can cluster your data based on the time, a column in that data. So it is still row based. That means that if you were to invert that as you were writing it, then you have the most recent at the edge of the disk. So you're always, if you ever needed to go back 10, you're always getting really close. No full table scans or anything like that.
Yep.
That's the whole point of it. Cassandra does this. The approach to, getting any individual pieces of data or it's all denormalization really. So create a new table anytime that you want a certain subset really. So if it was daily roll-ups or anything like that, new table, always a new table. And again, going into the architecture of Cassandra, you were talking about co-locating Spark.
Yeah.
So the nicer approach to that is to actually have two clusters really. But you're doing that link across them. Yeah. So replication into the second cluster, which has Spark co-located on it. So that means that Spark isn't going to do the whole I want all your resources basically. Yeah.
So it's the term analytics workload isolation.
That's exactly what it is.
Yeah. So effectively, if you have typically Cassandra or HBase or any of these, NoSQL columnar data stores are serving a application somewhere, so they have SLAs associated with them. Yeah. So what you don't want is your data scientist to come in all, join happy and start running this big query that just kills everything. So
just goes down.
There are a number of strategies then to isolate those kind of workloads from the application. So typically, as you said, that would be like physically partitioning the nodes.
You had two sets of nodes using the replication to handle that then.
Yeah.
You don't need to care about it after that. So that's the end of that one. What I will say is that talk was really good if you wanted an introduction to all those bits and pieces, and the guy that ran that, I can't remember his name, Patrick McFadden. He has his own SlideShare, so the slides should be going up there soon.
Okay. So the final thing we just wanted to cover before we sign off and go to day 2.
Yes, day 2.
Day 2.
The big day.
So we've got some keynotes coming up.
We do.
From Doug Cutting and various others on the future of Hadoop. So this is like the 10-year anniversary of Apache Hadoop that they're sort of celebrating in parallel with this. But anyway, so we'll do the Tech Watch. So this was kind of, we're trying to keep an eye out for what are the hot topics at this conference. So no pun intended, Kafka is one of those. Interesting things happening with Kafka. I mean, it's one of those things where it's kind of becoming the de facto choice for the use cases we've been talking about. So really high throughput, really low latency streaming. You know, Kafka is the choice for that.
Yeah, it's just going to be the thing.
The only other comparable thing I can think of is Kinesis from Amazon, which effectively is Kafka. You know, they're basically taking Kafka and it's delivered as an AWS service. One interesting thing that's coming with Kafka is Kafka Streams, which is actually out this week, I think, or in the past week. What Kafka Streams is, this was like a bit of insider knowledge from Gwen Shapira on the fraud detection talk. Effectively, Kafka, they went to SAMSA. So the SAMSA is effectively an alternative to Spark streaming. It's a stream processing framework. So what they wanted to do was to have SAMSA not dependent on Yarn. So SAMSA is dependent on the Yarn resource manager. The SAMSA guys were like, we're not kind of really feeling that. So Kafka effectively have re-implemented SAMSA minus Yarn as their own stream processing framework, and that's now called Kafka Streams. Kudu is another interesting one. So Kudu is kind of seems to be being pushed by Cloudera quite a bit at the moment.
It is.
Effectively, what it is a new storage layer. So it's a new storage manager for Hadoop. It's effectively something that sits in between HDFS and HBase, if you want to think of it that way in terms of features. So if you're not aware, HDFS is all about, you know, append-only storage, you know, scans, really efficient at streaming stuff from and to disk. HBase is more the case where you're wanting random updates. So the classical kind of problem that Kudu solves is this use case where you are having data coming in from a streaming source like Kafka, and you don't want to write that data directly to HDFS as lots of small files, because that's a problem for HDFS. Effectively, that kills your name node eventually. So what you do is you incrementally write all those little updates to HBase, and then, you know, that's like a 15-minute window, let's say, in your HBase tables, and then every 15 minutes you roll that data up into a big file that you write to HDFS. So Kudu effectively cuts out the need for both of those things. So you can do that use case all using the one storage manager. So it gives you the random writes, random inserts, but you can still do the HDFS kind of access pattern as well. And in terms of performance and features, it's kind of in the middle.
So does it still require HDFS?
No, it doesn't. Okay. It's not dependent on HDFS. It's a completely new storage substrate. So, you know, SQL engines, things that sit on top of HDFS currently, like Impala, for instance, can sit on top of Kudu as well, which is interesting.
Impala is quite hard pushing to be on Kudu. It's all there. It's basically built with Kudu in mind. Kudu and Impala go very well together.
Okay. Both kind of deer antelope looking things. So okay.
Yeah, makes sense.
Spark is, I mean, again, it's another one of those things where it's the de facto choice for a distributed processing engine. It's basically killed MapReduce. So there was an interesting poll of hands during the architecture talk where they're saying, no, show of hands for anyone who's used MapReduce, for anyone who's used Spark, and for anyone who's completely skipped the MapReduce step. So people have adopted Spark as their processing framework first. They've never had any kind of dealings with MapReduce.
That's interesting, because
so we're at that point.
There was absolutely no mention of MapReduce yesterday.
Yeah. Yeah, it's kind of off the table. So interesting things about Spark. Data frames that you mentioned, Spark 2.0 is coming in April, I believe. So that's going to be a big change in the core processing engine for Spark. Controversial statement of the day was Ted in Alaska with Cloudera saying that effectively Storm is now legacy.
Yeah.
Which is interesting thought. But basically his position was that Spark, Flink, Kafka Streams, Samza, I guess, these are going to be the kind of battling out for the space going forward, and he didn't see Storm as being part of that. Yeah, so interesting. Cassandra then was one you were more interested
Cassandra really, for me anyway, it's more the simplicity of the NoSQL side of things and the linear scale, basically. Really what lies out there that used to try and handle this kind of massive data in a NoSQL fashion or a SQL fashion even in the past, it's been the big hitters, the massive multi-million pound appliances, which is really where Cassandra comes in and says, this might be a good use case for us, which is great. It's really the situation, in my opinion, anyway. If you weren't going to go for something that's really still licensed, I guess. So Cassandra is Apache, so that's okay. Anywhere that you weren't looking at the likes of Hadoop and HDFS, so you wouldn't have Cassandra and HDFS. So that's really the way to go with things, in my opinion.
Okay, right. So with that, we are going
need to go and get breakfast.
Trot along to get breakfast very quickly because the keynotes will be starting in around 15 minutes, I think. So it's going to have to be a quick one. So thanks very much for watching. We will be producing another one, I think, tomorrow morning. The reason we're doing it in the mornings is there tends to be quite a lot of events in the evenings, kind of networking events. So
we're still on UK time.
We're still on UK time internally, so we're kind of both up at
5 a.m.
in a way. So thanks very much for watching. We hope you found some of that useful. There'll be more detail in the description, as I mentioned, and we'll see you tomorrow with day 2.
See you.
Bye.
Thanks.